We're going to use the Suvat equations to find the greatest height reached by a stone, the speed at which it hits the ground, which is like the final velocity in Suvat, and also the time taken for the whole journey. So let's take it step by step by going through part A first. I'm just going to write out Suvat like this. Now let's think about it. It's going to start 2 meters above the ground, like it mentions, with a speed of 18 meters per second. So that will be the initial velocity that it starts off with. Now if we're looking only until it reaches the highest point, what we know about the highest point is the velocity is actually equal to 0. Now the reason for that is because velocity is a vector, it depends on direction, meaning if it's positive in one direction, it's negative in the other. So if we take velocity as, let's say, a positive one just before it changes direction, going upwards by the way, then we say when it's going downwards, it'll have a negative velocity, something like maybe -1, for example. But in order to go from a positive to a negative velocity, you have to cross 0, which is what happens at the highest point. The acceleration, well, because it's going upwards, it's going against gravity, so it will be minus 9.8. 9.81 would be used in A-level physics, by the way. That gets confused quite a lot. What we're trying to find is greatest height reached. If we find the displacement that it needs to move to go from here to its highest point, and we add onto that the 2 meters that is above the ground originally, that'll give you the highest point, or the greatest height reached. So let's do that. The variables involving SU, V, and A, the equation, is this one here. V squared equals U squared plus 2AS. So let's put it into that equation. V squared is 0 squared, which is 0, equals U squared, 18 squared, plus 2 times A, which is minus 9.8, times S, which we're trying to find. Straight off the bat, 2 times minus 9.8 is minus 19.6. So I'm going to write this as minus 19.6 S. Add 19.6s to both sides, and then divide both sides by 19.6, and that will give you the displacement that it moves from where it starts to reach its maximum height. So let's find that. 182 over 19.6 is equal to 9.28 meters. And so the greatest height reached is 2 plus 9.28, so that's 11.28. Great. Let's move on to part B of this question. I'm just going to quickly rub some of this out because it's taking up too much space. What is asked for now is the speed at which the stone hits the ground. So now we have to use Suvat for the whole journey and not only a part of the journey. So from where it starts to when it reaches the ground, the overall displacement is minus 2 meters. The reason I wrote it as a negative is because throughout the whole investigation, we took going upwards as positive displacement. So if it goes in the opposite direction, it has to be negative because it's a vector. Also, the displacement is the distance from your starting position to your ending position, which is why even if it moves a certain distance throughout the journey, we only consider the start and end position. And so the distance between that is minus 2. It still starts with a speed of 18 meters per second. It's still starting off going against gravity, so we still use minus 9.8 as our acceleration. And we want to find the value of v, the velocity just before it hits the ground or just as it hits the ground. The equations again involving SU, V, and A is this number 3 one. So v squared is equal to u squared, 18 squared, plus 2 multiplied by A, which is minus 9.8, multiplied by S, which is minus 2. I'm going to quickly put all that into the calculator. So that's 18 squared, 2 times minus 9.8 times minus 2. Oops. And that's equal to, oh, sorry, that number looked outrageous. I think I substituted something. Yeah, I substituted that incorrectly. It's actually equal to 363.2. Got like 10,000 before. Great, now you square root both sides and you get that the velocity is the square root of 363.2, which is 19.05. We'll just say 19 meters per second. Yeah, so the speed would be 19 meters per second. By the way, if you took velocity as positive 18 when it started off, which we did here, the final velocity would actually be minus 19 meters per second because it's going in the opposite direction as it hits the ground. The reason that's available to be used is because when you square root something, there's a positive and negative root. Okay, it's taking quite long. Let's quickly move on to part C of the question. Calculate the time between the instant the stone is projected and when it hits the ground. So once again, we use Suvat for the whole journey, like before. The displacement is going to be minus 2 meters for the whole journey. It's starting off against gravity, so acceleration is going to be minus 9.8. We know that it starts off with the speed of 18 meters per second, and we want to find the value of t. This is where we use the equation involving SU, A, and t, which is the hardest equation to use, s equals ut plus half a t squared. So s is equal to 18t plus a half of a is a half of minus 9.8, so that's minus 4.9 t squared. Let's take everything to the left hand side, so it's a positive t squared term. 4.9 t squared minus 18t minus 2 equals 0. And then from here you can just use the quadratic formula. So I'm going to quickly do that. You can skip ahead 20 seconds if you'd like. Root of b squared minus 4ac all over 2a. Okay, so the first answer gives you a negative value of t, which of course is impossible because time can't be negative. And the other one gives you a positive value of t, which is possible. So that's what you choose as your final solution, which is 3.78 seconds. That's everything for this question. If you have any questions with it, just let me know in the comments. Otherwise, like the video if it helped, please. It'll mean a lot. Also, be sure to subscribe. I'll post a new video every single day. And if you're interested in any tutoring, any group tutoring or one-on-one tutoring for A-level maths, just send me a message I've linked my email in the description.